Here we go. Pre-Calc B, Unit 11 practice test. Plot the polar coordinates, label with the appropriate letter A, B, C. 4. So remember, polar coordinates are r theta. So our r is 4 units long. There's my spinner out to there. I got to spin it down. 60 times 2 is 120 degrees. So this is 90. And remember, every 2 chunks is 30, every 1 chunk is 15. Kind of helps you to keep track. So 270, I got to go 30 more, would be right to here. So there's my point right there, point A. Why aren't I going polar opposite? Because my r isn't negative. Here it is. So now I got to think, step 1, find that point. So my spinner is 1 unit long. Got to go pi, which is here. But then that negative is there, which means polar opposite, which takes me right back to here. So that's point B. R is 3, up 90. Zip. And there we go. We stopped there because my r is not negative. So this says convert the rectangular equations into polar equations. Well, remember our little formulas: x equals r cosine theta, y equals r sine theta. And I want to show you guys something. You will have this formula sheet at your disposal. So it's got everything you can need as far as I can figure. If I'm wrong, we'll add something. So, and then we got x squared plus y squared equals r squared. So there's our 3 formulas. So here we got a y. We're going to replace it with r sine. So 4 r sine theta. We got an x. So minus 3 r cosine theta equals 3. Remember, when we're trying to find polar equations, we're done when we get r equals some stuff. So we have an r here and an r here, so we're going to factor out an r. 4 sine theta minus 3 cosine theta equals 3. So we're going to divide by this. We're going to divide by that over here too. So I get r is 3 over 4 sine theta minus 3 cosine theta. We're done. There's nothing you can do with that. This one's going to require some more work, so you have to FOIL this out. Don't square this and square that. I think you're good. That's x minus 2. X minus 2. X times x is x squared. Outside, inside, minus 4x plus 4. Same thing here. Y plus 1, y plus 1. So we get y squared, outside, inside, 2y plus 1 equals 4. Okay. Let me pause this just a moment. Alright, so I'm just going to correct this. These are handmade by mathematicians, so everything works out well for us. So, if you recall, this number and this number on all the problems we're practicing are going to cancel with this. So this is supposed to equal a 5. Because if these cancel, then we look at this and we go, hey, x squared plus y squared, we replace that with r squared. And then minus 4x is minus 4 r cosine theta. This would be plus 2r sine theta. Wait a minute. Give me a second here. Maybe I'm wrong. Okay. Under some deep probing, investigating, yes, this is the way it's correctly written. So that should equal 0. And so then what do I do here? Well, remember, we're not done until I have r equals some stuff. Have an r, have an r, I have 2 r's, so I'm going to factor an r out. So I'm left with 4 minus 4 cosine theta plus 2 sine theta equals 0. Remember, we got two scenarios. One, r could equal 0, but we know that is not radius r can't be 0. So that means this, r minus 4 cosine theta plus 2 sine theta can equal 0. So I'm going to add 4 cosine theta, subtract 2 sine theta from this side and that side. So r would be 4 cosine theta minus 2 sine theta. And we did it. But yeah, that needs to be a 5, because those constants need to cancel, or else it will turn into a complete nightmare. Now we got to go in reverse order. Convert the polar equation into rectangular. So we need our squareds are good, and our cosines are good, our sines are good. So with that being said, our squareds are good. So we're like, ooh, it'd be nice if I multiply that by r. But if I do it to this side, life is good, because I get r squared equals 2r sine theta. This turns into x squared plus y squared. This turns into y, so equals 2y. So it's that easy if you see the initial trick. Same thing over here, but we got a little twist. We need cosine, we need sine, so that we can get r sine, r cosine, which means this secant's doing us no good. So instinctively, get rid of it, and things just kind of work out. Divide by secant, divide by secant. Now what is this? Well, what is the reciprocal of secant? Because there's a 1 over secant, which is the same thing as cosine. But where should I put that r? On the end? Nope. Put it in the front, because then we'll recognize it. R cosine theta equals 4. So then, we are going to divide by cosine, because we got to solve for r. Divide by cosine. So we get r equals, what am I doing? You are seeing a teacher just have a meltdown right in front of your face. So the whole dividing by secant, good idea. Divide by secant, good idea. So this is the same thing as r cosine theta equals 4. Well, I forgot that we're trying to get it into rectangular. I went to la-la land. So what's r cosine? X. X equals 4. I almost kept going. So we got u, 5 minus 2i, v, 4 plus 4i. Find the distance between them. All right, well, we're going to plot that point. 1, 2, 3, 4, 5, down 2. So essentially it's 5, negative 2. Yes, there's a spinner there, but we're really talking about the distance between these 2 points. And 4, 1, 2, 3, 4, 4. So it's really 4, 4. So x1, y1, x2, y2. We can call this x1, y1 and this x2, y2, so that doesn't matter. Now the distance formula is given to you, but it is x1 minus x2 squared plus y1 minus y2 squared. So, put things where they belong. What's x1? 4. What's x2? 5. But we have to square that. Plus, what's y1? 4. Careful with these. Minus and negatives. That's a minus squared. So that's negative 1 squared, which is 1. This is 6 squared, which is 36. So the distance is the square root of 37. All right. What's v minus u? Well, be careful. V is over here, u is over here. So that's 4 plus 4i minus all of it. So you got to insert your parentheses just to be careful. So that would be 4 minus 5 is negative 1. 4i minus a negative 2i would be 6i. Because a negative and a negative make a positive. So now this is saying what is the modulus, or the distance, of that? We just found v minus u, so now they're saying find that modulus. So, -1, 2, 3, 4, 5, 6. Drawing's not going to be perfect. So, that's what we're trying to find. Well, if this is -1 and that's 6, we're going to go a squared plus b squared equals c squared. So it's 1 plus 36 is 37. Take the square root, and they're the same. All right. So, midpoint of u and v. Well, there's a formula. It's just u plus v over 2. You're just finding the average. So, you're finding the point in between here. So, 5 plus 4 is 9. Negative 2i and 4i is 2i over 2. So if I figured that out, divide this, it would be 4.5 plus I. So that's really going 4.5, 1, 2, 3, 4.5, and then up 1. It definitely looks like it's in the middle. So that's it. Yeah, you could write it 9 halves plus I. Same thing. You're worried about that? Okay. What is the modulus and the argument? Remember, argument is how far you spin the spinner to get there, but there's limitations, and that's it. So, what's the modulus? Well, it's the distance. This one, 4, 4, hopefully it's jumping out at you that this is a 45, 45, 90. So that one is V. So the modulus of, of V is 4 square root of 2. Argument, we just talked about that. That's 45 degrees, or pi over 4. Now this one's going to be a little bit more complicated. So I'm going to redraw it over here. So we get 5, negative 2. Well, there's no little family here, so I gotta go a squared plus b squared equals c squared. 25 plus 4 is 29. Take the square root. There's the modulus. Now, how do we find the argument? Well, we're going to put a little fishy in there, alpha, and I'm going to go tangent of alpha fishy opposite over adjacent. Get out my calculator. Second tangent, negative 2 divided by 5, negative 21.8. So this is negative 21.8. In other words, it is 21.8. But to find the argument, I'd have to subtract that from 360. 21.8. Try this into my head. 338.2. Okay. There it is. All right. Now here we go. Different language here. If V is this, W is this, Z is this, find the following. Well, what is this? That's just asking what's the conjugate of W. Well, that would be the square root of 3 minus I. This is just saying take V, 3 plus 4I, multiply it by its conjugate, 3 minus 4I, and if you remember, we can just fill. So 3 times 3 is 9, minus, because a positive times a negative is minus, 16I squared, which is the same thing as 9, plus 16, which is 25. This is saying, what's the modulus, or the distance, or length, of the conjugate of Z? That's a mouthful. So this is saying, take the conjugate, 5 plus 2I, and plot it, 1, 2, 3, 4, 5, 1, 2, so there's 5, 2, and figure out that length. Well, that's 25a squared plus b squared equals c squared, 29 equals c squared, so I get the square root of 29. That's what this would be. Now they're saying, find the modulus of W. Well, I'm going to squeeze this in here. That means go to the right square root of 3, which is 1.7, and go up 1, which is not very far. I'm going to put the square root of 3 down here so this doesn't get in the way. So that's 1. And hopefully you're starting to see something. This side is this side times the square root of 3. So this must be a 30. Has to be a 60, making that 2. So that is 2. Simplify. Well, careful. Don't just cross out these. You can't. Or cross out these. You can't. Ignore the numerator. The numerator is just tempting you to do stuff wrong. This is just saying, hey, multiply the denominator by its conjugate. But if you do that, then you have to do that to the top as well. Down here we can fool. Up here we have to FOIL. So this times this, 16. Outside inside would be negative 8i square root of 2. Now this is where it's going to get messy. A negative times a negative is positive. I times I is I squared. Square root of 2 square root of 2 is 2. Now I'm going to go ahead and clean that up. This right here is 2 times negative 1, which is negative 2. 16 minus 2 is 14 minus 8i square root of 2. That's the numerator. Denominator, 4 times 4, 16. Positive times a negative is negative. I times I is I squared. Square root of 2 square root of 2 is 2. Now what is just that in the box? Well, that would be minus 2. 2 times negative 1 is negative 2. These two negatives make a positive. 16 and 2, 18. Now I can see I can take a 2 out of all this, so I should. 7 minus, 4 I square root of 2 all over 9. And you can see multiplying by the conjugate gets the radical out of the denominator, and that was the whole point of the problem. That ends part 1.